Hello everyone, welcome to this new video. In this video, I am planning to create a Flask based web application, and I would like to call this application a smile detection app. Now, the purpose of this app is going to be it will provide a interface where we can upload our image, and then it will provide us with the recommendation, not recommendation, but rather the prediction of whether the face that is there in this image is smiling or not. So this is the whole idea of this app. So now earlier I thought that maybe I'll create my own data using web scraping, where I will create some scripts which will download me some smiling and non-smiling pictures from internet. But then I realized that this particular idea will involve some complications, because I'm downloading images from online websites, and they might contain some images which are not like free. Okay, so that is why I decided to not go ahead with that idea, and instead what I am going to do is I'm going to utilize a data set which is readily available on Kaggle, and use that data to train a very simple model, because the idea is to teach you guys how to create a interface where we can upload the image and take that image in the backend and utilize our pre-trained model to make the predictions, and finally render those predictions to the front end. So this is the whole idea. So what I'm going to do is I'm going to first of all create a folder for our app. Okay, so I'll say let's call it smile detection, maybe, although the name doesn't matter, but let's call it smile detection app. Okay, now in this particular folder I'm going to first create, sorry, not folder, but I'm going to create a text file. Now this text file's idea would be to just keep track of where are we, because I am planning to complete this whole video in one video. I do not want to split this particular tutorial, although there are many different components to this app which can be taught in their own separate videos. But I assume that you all guys have some familiarity with Flask. Little bit familiarity would be okay. Even if you are not familiar with it, then I'll try my best to explain those as we go. Okay, so yeah, so I was saying that I'll try to complete this video, I complete this app in one video rather than splitting it into multiple videos. All right. Okay, so first I'm going to create some virtual initial setups in the form of virtual environments. Okay, so let's do that. Okay, so we have this command prompt ready, and in this command prompt, obviously I have Python already installed. If you don't have Python already installed, you would need to go to python.org and get the latest installation done. Okay, and it is not a very difficult thing to do, so I'm leaving this step to you. Okay, so now with Python's so with Python's default version, you will get one virtual environment tool called when. And using when, what we can do is we can do Python underscore hyphen m, and when will be the program name, and finally the virtual environment name. Let's call it smile detection when. Okay, smile detection when. Okay, it will take a couple of seconds to create this virtual environment, and if you see in this folder, we will have this new folder which will have some packages and initial scripts like pip and all. Yeah, it's done. So now we can activate this environment by doing this. So I'm writing the name of the folder, / script / activate, and if I hit enter, so you will notice that now we are in that virtual environment. So up now what we will do is we will install all our packages in this virtual environment, and it will not affect the default Python which is already there on my system. Okay. Okay, all right. So now I already have Visual Studio Code installed on my system. So what I can do is I can do code. Now when you enter code, this command prompt understand that I am referring to VS Code, and if I hit dot, then it will create a project kind of thing in the same folder. All right. And if you don't specify this dot, then Visual Studio will just open the Visual Studio Code for you. Okay, so it's good to enter the dot thing, and you will say yes, I trust this author. Okay, so we got this project now. We have this plan.txt and we have this virtual environment folder. All right, now in this plan.txt, let me create a rough plan of how I'm planning to create this app. Okay, so the first overall objective would be to train a smile detection model. Okay, so this is the overall objective, and let me just get rid of this because we are already getting these numbers. So I'll just get rid of this number. Yeah, so train a smile detection model and save this model as pickle. Okay, so I want to save it because I do not want to run this model all over again when the user uploads their image. Okay, we want to have one production model ready. Okay, so now this itself will have some sequence of steps. Let's not write those as of now. Once, let's suppose my model is ready, my pickle based model is ready. What will be the next step? So the next step would be to build a Flask Web App which uses that model. Okay, all right. So these two will be the broad things that we need to accomplish. Now under each of these we have some sequence of things that we need to achieve. Okay, so first thing is get the data. Obviously, get the data from Kaggle. Okay, once we have the data, we need to read the data into Python. Okay, we need to prepare the data which sklearns model accepts in a form which it accepts. Okay, finally train a model, and fifth save the model. Okay, so these are the sequence of steps that we need to complete, and this will serve as a guide which we can reference again and again to kind of see where are we in our app during this entire discussion. All right, so in the Flask Web App thing, I'm going to create a HTML page which will accept image as the input. Then that image will be read in the backend, and it will be pre-processed. You can say pre-processed because this kind of pre-processing that we are doing on the training, which we need to do that same kind of pre-processing to the input data that the user has entered. So it will be pre-processed. Finally, model will be used to make the predictions. Okay, so now we have this this framework ready. Now we can go ahead and try to complete each of the tasks that are listed there. Okay, so first thing first, I'll go to the Kaggle and I'll write smile detection. So I have this page ready, and from there I'll just hit download, and it is saying me I need to sign in. I'll just sign in with my default account, default Google account. Okay, so we have this ready. Now let's try to download this. Okay, so yeah, it has been downloaded, and let me show this downloaded file in the folder. Why it is not working? Let me go to download. Yeah, so we can see this archive.zip. I'll cut it and I'll paste it in our folder. Let's see, let's extract this file here. I'll say extract to archive. Yeah, it will take 2 or 3 seconds. Okay, so we have this archive folder. I delete the zip file. Now, out of all these files, we have we want to get this dataset folder. So I'll just cut it and I'll delete the rest of the folders. Okay. And in the dataset folder also we have two kind of folder, test folder and train folder. I do not want to have these two as a separate thing. So what I will instead do is I'll just go in the train. So in the train folder we have two folders, 0 and 1. One stands for those faces which contain smiling faces. So you can see here we have these smiling faces. But if I go in the 0 folder, then these are neutral faces, so they are not smiling, although there are some exceptions here, but more or less this 0 folder contains those images which are not smiling. Okay, so what I will do is I will create only one folder for 0 and 1, and I'll merge all these train and test thing. Okay, so I'll paste this in data and I'll just delete this train folder. Okay, and let me do that. Okay, in the test I'll go to 1 first and I'll cut all the images, and I'll go to 1 and I'll paste them right here. Okay, so now we have train and test merged. Okay, now in the test folder again I'm going to go to the 0 folder and I'm going to paste it with train data. So now we have train and test merged, because we will be making a train and test split, obviously, just to see initial level performance. But just to tell you one thing, that this tutorial is not about how to improve your models. This tutorial is just about to create a basic model and get it into production using Flask. Okay, so now if I go into the one folder, we have around 2100 smiling images, and if I go into the 0, we have around 1800 non-smiling images. Okay, so it's kind of pretty balanced data, so you cannot say it is a imbalanced data. And if you are little bit comfortable with machine learning terms, then you would understand that with a balanced data, accuracy is a as good a measure as F1 score. Okay, so in the unbalanced data situation, we need to use other metrics such as F1 score, recall, precision, etc. Okay, all right, so we have this data set ready. So this was our first step, right? So we had to read this data. We have to get this data from Kaggle. Now I'll create one script. Okay, and this script is going to be called, let's say, data preparation, maybe. Yeah, data preparation and modeling, because I'll just create model and everything in this particular file. Okay, now so this particular file is going to read all of the images data that we have just prepared, like zeros and ones, and it will create a machine learning kind of data using this app, this particular file. Okay, now so how do we read those images? To be honest, if you just search online as to how to read images, you will get around thousand of different ways. You can read a image using matplotlib. You can read an image by skimage. This is a package just like sklearn. You can read an image with a package called pillow. There is this module called pil, Python imaging library, and there is this sub module called image in the PIL. You can read that from again, obviously from there. Okay. So how are we going to read these images? It doesn't matter, as long as we are able to get the images in that array format. uh, as long as we can get the numbers out of images, it simply doesn't matter. So just try to just let me go at this step one by one. Okay. So what do I need to do? First, let me create some variables for path. Okay. So I have this dataset folder. Okay. And I have this zeros folder for zeros and ones, right? So what I can do is I can create, let me go inside the zero folder. I can copy this path and I can create a variable called, let's say, negative images folder. Okay. And I'll paste it right here. Okay. So what I have done is I have copied this zero folder and I have pasted it right here. And if you are familiar with Python's string and how it escapes this particular, how this particular string is actually a string to escape, you would need to add this R to it, because R stands for raw string. So it is just taking everything as a string. Okay. Now I'll just copy this whole thing and I'll say let me add positive images folder. Okay. Or maybe I should have used, let's say, maybe smiling images here, but it doesn't matter. Okay. So I'll just replace 0 from 0 to 1. Okay. All right. So now I have these two paths ready. Now what I can do, I can do one thing. So I need to read all these images, but I need to get the path of these images, right? But right now I'm having path of the folder, not the path of images. So I can import one package called OS, and OS has this function called os.list directory. Using that I can list all the images. So I'll say positive images. Okay. Positive images will be os.list directory, and I'll say positive images folder. All right. Negative images is equal to os.list directory negative images folder. Okay. Let's quickly print one of these to make sure we are getting correct results. Okay. So I'll go to the command prompt and I'll say Python and data preparation. Yeah. So if you see, we are getting the correct paths, file and then its extension. All right. So this part is working correctly, but we just got the file names. We did not get the whole path. So to get the whole path, what I can do is I can just run a loop over this, and I can merge this folder path and this individual images path. Okay. So I'll say final or maybe I can say images, positive images path, positive images path. Okay. I'll use the dictionary comprehension, and I'll loop over for image in positive images. And what I need to do is I need to take this positive image path, positive images path, which is this. Oh, okay. I think I renamed. I should have used full path here. Let's say full path. Yeah, positive images full path, positive images path. Or I should have used this only. Yeah. So positive images folder path plus. Now I need to add one forward slash to the end of this path. So I'll say forward slash. But in Python, forward slash, as I mentioned earlier, doesn't work. So I need to add double forward slash here, or I could have done R here. Okay. So I'll just add 2 forward slashes, and I'll just add this image name to it. Okay. Once I do this, my So positive, I looped over positive images. Let me decrease the size a little bit so that you can see this thing. So I looped over positive images, and I appended the name of the image to the absolute path. Okay, so I'll just copy this again, and this time I'll change this to negative, maybe. Okay, negative, negative images full path, and I'll say negative images folder. Okay, for image in negative images. And let me to make sure that I got this thing correct, so I'll say positive images full path. I should have used full path, and let me print the first image. Okay, so let's run this code again. Yeah, so we are able to get the uh, get the name of the images, get the full path of the images correctly. Okay, so now this first part of this is ready. So what I can do is I can wrap this whole thing in a function. I can write, let's say, get images path. Okay, I can have this function, and I can just indent all of these code to this, and I will return what? I'll return these two paths. Okay, cool. So I have this function ready. Now I need to read the images. Okay, how will I read the images? So to read the images, first step is obviously to get these paths. So I'll do positive images, positive paths, maybe negative paths, and I'll call this function get image data, get images path. And the moment this function is called, we will have positive and negative paths. Okay, so how will I read this image? So let's for the sake of it, I will play with the first positive image. Okay, and the way I'm going to be reading this image is by using the PIL library, but I will have to first install this library first. So I'll say pip install pillow. So pillow is the name of the library. Okay, it is installing, and it is installing, remember, in the virtual environment. So I'll say from PIL, I'll import the image class. Okay, now there is a function called image.open. Okay, so I'll say image.open, and I'll specify this demo path. Okay, and let me call this, let's say, im stands for image. Now how do I show this image? So I can say im.show. Okay, so let's run this and see whether we are able to read this image or not. Can you see this? We are able to show this image perfectly fine. Yeah, so what is the next step? The next step, we don't want to show this image, but rather we want to create a numeric kind of data from this image data, from this image file. How can I do that? Now in Numpy, there is a function called asArray, np.asArray, numpy.asArray, which can take this image, and it can convert this image into a array, into a numeric representation of an image. So to use that, I will have to first install Numpy. Let's wait for 2-3 seconds. It will probably take some time. Yeah, so meanwhile I'll just write the code that I wanted to write. So I'll say, yeah, it has been installed, I guess. Yeah, so I'll say import numpy as np. Now what I can do is I can do im underscore array is equal to, I'll say numpy dot as array, and I can specify this im thing. And if I now print this im array, let's print this. Okay, and see how does it look. Oh, so can you see this? So we are able to get these arrays. Now you should be a little bit comfortable with RGB thing. RGB stands for red, green and blue, which is essentially a computer representation of how a image is represented in a computer. So each pixel in a computer is represented by these three values RGB, and some representation also include the fourth representation, which is for alpha, how transparent that each pixel will be. So that is controlled by the alpha. But what I'm currently here referring to is three channels. So we have height and width, but each height and width, so each combination of height and width is further decided by three values, and those three values are essentially red, green and blue. Okay, so let's quickly print the shape of this array and see how does it look. Okay, so 64 is the height, 64 is the width, and 3 is for channels, which is for RG and D. Okay, so now we got this shape. But in machine learning, what we do is we usually unroll it. And by unrolling, what I mean is, so what we have is 64, 64 and 3. So what I can do is I can reshape this whole image into so whatever this value, I think this value is going to be around 12,000. So I'm going to get a value, I'm going to get 12,000 features, you can say, okay, for our machine learning task. So what I can do is I can write image array is equal to image array dot reshape, and I can reshape it to 1 into -1. Now it is going to reshape this image array into so the first shape will be 1, and the remaining shape it will calculate on its own. So how it is going to calculate? So earlier its shape is 64, 64 and 3, right? Now we have told this reshape function that hey, you have to take the first shape as 1. So what will be the second shape? It will just multiply all these three numbers, and it will say okay, the second shape should be the number of elements in the second dimension should be this much. Okay, whatever the result of the multiplication will be. All right, so now we get this function, but we are doing this for only one image. We have to do this for all the images, for all the positive and negative images. So right now the idea is this only, okay, that we will read these images and we will reshape it into this form. So let me quickly show you by printing its shape once again. Can you see this? Now its shape is 1 by 12,000, and this will be the result of this multiplication. Okay, cool. So now that we know how do we read this image, what I can do is I can have a let's say empty list, and I can loop over, let's say, for paths in positive paths. Okay, since I have these ready, so I'll say okay, now I don't need to specify this demo thing anymore. So I have this paths, so I'll say paths here. So now I'm reading the current image, and I'm converting the current image into array, and I'm reshaping it. Now rather than printing the shape, I'll just append to it. Okay, so I'll append the current image array. Okay, now I need to do the same with negative images. So I'll say for paths in negative paths, it will just create a data list which will hold all the image array, all the numpy array of the shape 1 by 12,288. But we have not tracked the class of the images. So what I will do is I'll create a list called labels, and I'll add labels dot append. Now since this is a positive path, I'll just add 1, and this is a negative path, I'll add 0. Okay, so now we will be having one data list and one labels list. What is the next step? The next step, okay, so in machine learning, if you are experienced with it, you would understand that in machine learning we have a data in the shape of number of examples by number of features. Now we have only one images as of now, and we have many such images. We have to somehow stack them. So to stack them, I will use a function called let me use that np dot vertical stack, and I'll just specify the old data. So old data is a list of all these images of shape this. So it will just stack this, and in place of one, now I will get the whatever number of images I have. So if I now print the shape of this, let me print the shape of this data. You will see it would be around I guess 3000 maybe. Let me run it. It will take some time because now it is reading all the images in negative and positive paths. Let's wait for 2-3 seconds. Meanwhile, okay, so now that we are having this data, now what I'm going to do is after yeah, so it has printed. So it's around 4000 images, and 12,000 will be the number of features. So we have just vertically stacked all the images. Now I will create a data frame. Okay, so let me create a numpy array first. Okay, so I'll say df is equal to pd dot data frame, but we don't have any pd package yet. So I'll say pip install pandas, and you would understand why I am creating a data frame in a moment, because I have to resample it. Right now what the order, if you see, in which positive and negative paths are appearing in the labels, all the first 2000 entries are corresponding to positive, and all the last 1800 or so entries are corresponding to negative, which is not good in a machine learning setting. So we have to shuffle it, and to shuffle this in pandas there is a very cool function which we will use. So import pandas as pd. Okay, so import pandas as pd. Now in the pd.data frame, I'll just specify data for now. Now in the next step, I can have a function, I should say a column for labels, and I'll just have labels here. Okay, so now I have this data ready. Let me print the head of this data. Head means first few rows. Okay, so let me run this code. Now it will take some time, obviously. Yeah, so can you see this? So we have all these 10 rows, we have 12,000 columns, and we have one label. But in the label, notice that we are having only once, like since we added once positive paths first, only ones are showing up, which is not good right now. So what I will do is I'll use a function called df.sample, and I'll use fraction is equal to 1. What we are doing is we are just taking sample from this data, and we are not taking less number of samples. We are taking all the, like if there are 4000 rows, we are taking all the 4000 rows as samples. Now what this will do is it will randomly shuffle all the rows so that zeros and ones are mixed together. Okay, in a shuffled way. And finally I will reset the indexes, and I'll say index is equal to false, in place is equal to true first, and drop is equal to true. Now what this drop is going to do is it will drop the index column, and in place will take the effect into the df. So let's run it for one last time, then our data preparation thing. Yeah, can you notice it? We have first 3 ones, and then 2 zeros, then 2 ones, then 0. So it is randomly shuffled, right? Okay, now that we have this thing ready, what I can do is I can wrap this also in a function. So I'll say I might create a function called prepare data. Okay, and I'll indent everything. So this prepare data is going to first read the paths, and it will loop through all these paths, and it will create this data, and finally this prepare data is going to return this df, this data frame. Okay, all right. So now we have these two, we have created these two functions. First function was get images path and the second function was prepare data. All right, now since our data preparation is done, now we can get ahead and start the modeling process. Okay, so how do I do this? For that, first let me install a package called sklearn. So we are almost done, like we are very close to our first step, and that step is to create the model and save that model somewhere. Okay, so sklearn is being installed. So I'll say let me create a function for modeling. I'll say x comma y, and let me create a classifier. First, is it installed? Let it install first. Yeah, so it has been successfully installed. Now what I can do is I can import some sub modules, sklearn.linear model, and I'm just using logistic regression for this tutorial because I do not want to improve the model. I just want to quickly get a model and use it in our app. Okay, so I want to also import train test split. Okay, so in the classifier I'll say logistic regression. Let me give the maximum iteration of 100. So I'll say classifier dot fit, and I'll specify the x and y which were passed, and I'll return this classifier. Okay, so this is a small function of model which will return as a classifier. Now what I can do is I can create a function. Okay, I can create a function which will run all of the things that we have just created. Okay, so what do you think the first thing that will be created? Obviously this prepare data, right? So I'll say df is equal to prepare data. So this prepare data is going to return us the the uh, the the required data frame. Now I want to be able to get the train test data. Okay, so how do I get this? So to use this function train test split, what I can do is I can create a function for splitting the data, and it will take the df, and we know that inside this df there is a function, there is a column called label which stands for the column that we are trying to predict. So I can create x and y, two matrices. How will I create it? So I'll say df dot location. So I want all the rows, but I don't want all the columns. I only want those columns which are not labels. So how will I specify this? I'll say df dot columns not equal to label. Okay, because I know that label is the name of the column that I do not want in x, but in y I want that column only. Okay, so I'll say df label, and I may want to have values here only. I do not want a data frame representation. Okay, so values, and once I have this x and y ready, I can specify train test split, and I can pass x and y, and I can also pass test size. Let's pass 30. So 30% of the data I want as a test data. So x train, x test, y train, and y test. So we have these ready, and I will finally return these to our main function. I hope that this makes sense to you. Okay, because these are not very difficult things. So finally we have this data. I will pass this data to this split data, and this split data is going to return me this train test split of my target and my main features. Okay, so finally I have this train and test ready. I can use model function to get me the smile detection model. So I'll say smile detection model is equal to model, and I can specify x train and y train. The moment this code is run, it will get me a model for smile detection task. Okay, finally I may want to check the accuracy. Obviously we know that logistic regression algorithm is not good with image related data, hence it will not work very best, but still it will work like average, not very good but not very bad too. Okay, so I'll get some accuracy. So to get the accuracy, there is this sub module in sklearn called metrics. So I can import accuracy score from there. Okay, and I may want to so let's get train predictions. So I'll say smile detection model dot I will need to predict, and to predict I will specify x train. Okay, and I'll say test predictions, which is going to be smile detection model dot predict and x test. Now using my actual labels and predicted labels, I can get train accuracy is equal to accuracy score, and in the accuracy score I can specify true first, which means y train, and train predictions, train preds. And similarly I can specify train accuracy is equal to accuracy score, y test, and test predictions. Okay, so what I can do is, so now I have these two calculations, train accuracy and test accuracy. Okay, so what I can do is, although I do not need to like print these things, but just to see the kind of results that we got, I can probably print to just to see what are the results that I am getting. Okay, so I'll say train accuracy is equal to train accuracy. Okay, okay, I'll say test accuracy is equal to test accuracy, and finally I need to run this final function. Okay, I think hopefully it should work, and yeah, I think we have done almost everything. So let's see how does it perform. Okay, all right, let's wait for 2-3 seconds. I think it will take more than I guess 2-3 seconds maybe. It is getting executed. Hopefully, fingers are crossed. It is going to work, because usually in one trial things never get successful. So that is why I am saying fingers are crossed. Let's see. Finally, last step would be to save this trained model in a pickle file. Yeah, so it has been executed. There are some warnings, and we were quite sure that there will be some warning, because this logistic regression is not a desirable model for this. So we are getting train accuracy, so it's a classical overfitting where we are overfitting on our training data, but still it doesn't matter. So what I will do is, now I will import pickle. Now import pickle. I think pickle is pre-installed. Yeah, pickle is pre-installed. And this smile detection model, I am going to dump this smile detection model. So I'll say pickle dot dump, and I'll specify this smile. Let me just copy this thing, smile detection model, and I'll open a new file. Now to save this this model, just save it right now in this folder, because later we will have to put this model in a static folder for Flask to use this particular model. Okay, so let's call this final model dot pkl, and I'm going to use write binary. So I'm opening a file. I'm creating a file called final model.pickle, and I'm creating that file as a in a writing mode, and I'm writing a binary form of this model, smile detection model. So finally I'm going to run this code for the final time, and this final time is going to create a final model pickle file in this folder. Okay, let's quickly run this file again for maybe 10-20 seconds, and it will create a final pickle file here. And with that, our first part will be completed, and then we can finally start with the Flask part. Yeah, can you see this? Now our final model pickle file is ready, and we will stop working with this file now. Okay, cool. So what is the next step? So the next step would be to start with the creation of the Flask app. And what will be the first step in creating a Flask? Let's first install the Flask package, and let's get the initial Flask app run very quickly. Okay, so let me do one thing. Let me install Flask first. So I'll say pip install Flask. Okay, so now in for the Flask, I'll create a file called app.py, and I'll import from Flask import Flask class, and I'll create a app called Flask, and I'll specify the name of the file, and I'll say if name is equal to main, then I'll run this file app.run, and I'll say debug is equal to true, obviously. Okay, so now I'll create a simple app.route, and I'll not specify methods as of now, and I'll name this route as index, and I'll return hello world for now. Let's run this app really quickly. I'll say python app.py. Yeah, so it is working without any error, and I'll go in my browser. Yeah, so this hello world is visible. Okay, so what are the next steps? Obviously, instead of this hello world, I'll render this using the external HTML files. So I'll create a folder called templates, and inside this templates I'll create index.html, and inside this index.html I'll quickly create a form. Okay, action. What will be the action? For action, we need to specify which function is going to run when this form will be submitted. We want to run this index function, so I will import the URL for here, and inside this index function I'll say URL for index. Okay, cool. And further I'll say method will be post, and there is one more thing that I need to specify, I guess. I don't remember it, but let's see. I guess file maybe. I don't know. because that makes sure that we can, but let's continue. Okay, so I'll say input and type will be files, and name, let's say image, because this name will be utilized when I'm accessing this inputted image in my server. Okay, so name is equal to this. I'll say accept only images. Okay, so all the images extensions are accepted. Let me specify one more wait a second, one more input, and this time I'll say submit. I think that the argument that I was saying, and type, yeah. So here I will see multi-part form data, because I don't know the reason for this right now, but this argument is required when you are trying to upload any file in the Flask form. Okay, so we have this submit button, and in place of app I'll say render template and index.html. so it will automatically look at the templates folder. So by default Flask looks at templates folder, and also I will need to change the methods to get and post. Okay, and I will need to import a object called request, which will enable me to check. So if request.method is equal to post, if it is post, let's for the timing return you have posted, to see if it works or not. And otherwise, if the method is get, I'll just return this template, this form data. Okay, so cool. So I think I do not need to restart this app. Yeah, so we can choose this file, and if I submit this, you have posted. All right, but notice here I'm able to post without even if I, so I will specify required here, so that required. Okay, so if I reload this and if I try to submit, yeah, so it says please select a file, you cannot submit it. So if I now try to choose any file, let's say okay, smile detection app and data sets, let me choose some file from here, and if I hit submit, you have posted. Okay, cool. So now I have created this initial setup where I'm checking for request.method.post, and I'm able to do this right now. When I'm making this request dot method dot post, now I need to get the image. So I'll say image is equal to request dot files. Now this is going to be a dictionary, and I can specify the key, and key will be the name of the file. So if you remember, here we specified the name as image, so I can get the image by the name image only. Okay, so I'll get this file. Now I can save this file, but to save this file I would need to specify the path. So I will have to do something like image.save, but in the image.save I need to specify the file name. Okay, so how will I specify the file name in here? To do that, let me create some more folders. Okay, let me create a folder called static folder. Okay, so I'll say static, and inside this static folder I'll maybe create a folder called images. Okay, so whenever the user is going to import or upload any image, this image is going to be imported in this folder. Now how can I get the path of this folder? To get the path of this folder, what we can utilize is, we can utilize maybe as maybe the os path.join. So how can I do that? Let's see. I can probably do, so first of all I'll say os dot path dot directory name, and this is going to get me the root path in which I'm writing this code. Okay, so I'll say absolute path, and I'll specify the file name. So wherever my file is, that will give me a root path. Okay, now once I have this root path, I can join using os dot path dot join, and I can specify, I can join as many paths as possible. So I can join static in the root path. Okay, and further I have, sorry, I think I ran this code mistakenly. So I'll say images. So I am joining this path static dot images. So I'll say this is going to be my, let's say, upload folder. Okay, so this is going to be my upload folder, right? Now after that, what I can do is, now our app is also ready. I can save this folder path in app.config. Okay, so I can say maybe upload folder. Okay, and I can specify this upload folder here. So what will be the idea? So I can do something like os dot, so I need to save this file, save this image somewhere. So I will say, but I right now I have this upload folder, but I will also need a file name. Okay, so I'll say os dot path dot join, and I'll say app dot config, and I'll say this, I'll get this upload folder, and wait a second, and further after this upload folder I will specify the file name. Let's keep this file name as maybe what should I say, image to test dot png. Okay, so I'm saving this image in this folder, in this images folder, as with the name image to test. Okay, all right, now using this image, using this saved image, I will need to make some predictions. Okay, I already have this model ready with the name final underscore model dot pickle file, right? So I need to somehow take this image from this folder and utilize that model. But first what I need to do is, I need to, let me go to the image detection app and let me cut this pickle file from here and let me save it in static folder. Okay, and let's copy this path final model dot pickle, and I'll say model folder is equal to os dot path dot join, and I'll say root path. Okay, so in the root path we have this file name called static, so I'll say static, and I'll say final model dot pkl. Okay, all right, so I hope that you are able to understand this. Again, after creating this model folder, let me see, in the static we have this, yeah, so we have this file, and I can again specify model folder in this app config, model folder. Okay, all right, so now I have this model folder. I need to read this model in this server and utilize this image that the user has uploaded to get me the prediction. So let me create a function to do that. So I'll say define make predictions maybe. Okay, now let me also import pickle here so that I can read the model. So I'll say smile detection model, and I'll say pickle dot load, and this time I'm going to open this file in a read binary format. So I'll say model folder and read binary. Okay, so once I have this, I can read this smile detection model and I can get the predictions. Now when I call this function make predictions, I already must have saved this image. Okay, so I'm hoping that this function is going to give me the predictions when I'm calling it after saving the image. So when I'm calling this function, so when I'm inside this make prediction function, I will expect this images folder to have one image with the name image to test. I hope that whatever I just said makes sense. Okay, so what I will do is I will load a image as image.open, but I need to import the image class from PIL. Okay, so image.open, and I'll need to specify the model path. So I can just copy this I guess, and it will make sense. So I'll say, yeah, so as os.path.join app.config upload folder and image to test. Now this image is going to be there. Finally I can do image to array. So I can do something like np, but for that I will need to import numpy also. Import numpy as np. Okay, so I'll say np dot as array, and I'll specify the image here. Cool. Okay, so now I have this array. If you remember last time when we read this image, what happens is we get the image in the form of 64 by 64 by 3. So this is one thing that I need to remember. But other than that, the user can upload the image in any form. So they don't know that we have created this model using 64 by 64 by 3. So hence I will say image is equal to image dot resize, and I can specify 64 by 64 here. Okay, so this resizing is important because it will rescale our image to the size on which our model was trained on. Okay, so images to array is done. Now finally what we can do is I can have this is equal to now what exactly I'm trying to do here. What I'm doing here is, if you remember in the beginning of this lecture, I have mentioned that in place of RGB sometimes images also have alpha values. To make sure that the user doesn't upload a image which has alpha values, or our image module doesn't load a image in the form of alpha, we are taking only the first 3 channels. We are ignoring the 4th channel. Okay, I hope it makes sense. All right, so finally I will reshape it in the form that our model expects. Okay, reshape, and this time again I'm going to use that convention, figure out what the shape should be. The first dimension is obviously 1, and the next dimension is going to be you have to figure that out. Finally I'll say predictions is equal to, I'll use the smile detection model dot predict proba, and inside this I'll say image to array. Okay, and finally I'll return these predictions, and these predictions is going to be returned here. All right, now how will I use these predictions? So to do that I'll say render template. I'll create a new HTML file, display.html maybe, and I'll pass these predictions as predictions. For now let's quickly create this template file called display.html, and I'll say let me quickly show the spreads first, and let's see if at all it makes sense or not, or if there is any error that we need to figure out. Okay, I think it's still working somehow, but I thought maybe let me break this and let me run this again. Okay, all right, okay, cool. So far it's working. Let me choose one image, let me choose this one only, and if I hit submit, Okay, cool. Yeah, it's working. So if you see, it is giving me this list of probabilities, and it is giving me the probabilities for 0 and for 1 and 0, sorry, for 1 and 0. So the way we can create this describe this display.html is, I can say something like maybe h2, I can say happy face probability. I can cut this. I think this should make sense, because when I'm passing the spreads in this render template, it is automatically passed to this HTML. This is a Flask convention. I hope you are familiar with this. Okay, so happy face probability, and I'll say unhappy face probability. Okay, now it would be nice if I can also display that image, maybe. Okay, that I uploaded. For that, see, whenever I am calling this display.html, I am hoping that user must have uploaded the image here. So what I can do is, okay, so this image is there in the images folder. So what I can do is, I can run a function URL for static, and I can say file name is equal to maybe image to test.png. Let me see if it works or not. Okay, so I'm hoping that this will give me the this will display the image for me. Yeah, nice. Can you see this? So this image is getting displayed here, and happy face probability and unhappy face probability. So I think we have created almost everything. So let's look at the plan for a moment. So we have created, finally model will be used to make the prediction. Yeah. So I think we have created the whole app, the thing that I was hoping for. So now you can maybe choose some other image. Let's look at that. So happy face probability is very low. Unhappy face probability, again, the model is not very good at predicting this, but still this should give you some motivation to maybe pursue something else. And unhappy, I think there is some mistake in this probably. Yeah, okay, yeah, I understand. Yes, so when sklearn returns the prediction, it returns for the 0 first and then for the 1. So I think it should be 1 here, but it doesn't matter. So right now we have not created our model as a very sophisticated model, but this can be obviously improved. But the whole idea was to create a model using sklearn, get the data from Kaggle, create a model, and then deploy that model using Flask, and enjoy, right? So so you are encouraged to improve this app. I'll put the entire code on my GitHub, so that you can also play with this code on your own, and maybe modify it, and maybe create something more sophisticated and more interesting. And yeah, play with this code and let me know if you have some doubts, or maybe if you want me to explain and create some more videos to explain more on these type of concepts. Okay, so thank you so much. It was a pretty long video, but I hope that you have learned something new. And yeah, so thanks for watching this whole video. And if you are new here, please don't forget to subscribe and hit a like if you like this video. Thank you so much. Have a nice day.